Section 6.2 deals with growth and decay. Before we start talking about growth and decay, let's review differential equations. Now, a differential equation is an equation that involves an unknown function and one or more of that function's derivatives. For example, y prime equals 4x squared minus 5x is a differential equation. So is y minus e to the 2x plus y prime equals 0. And so is x times y prime minus 5y equals 0. All of those are differential equations because they involve something that's unknown and the derivative. To solve a differential equation, the strategy is always to get all your x's on the same side and all your y's on the same side of the equal sign. So you want to separate variables. Once you've separated your variables, then you integrate each side of your equal sign. Now you have to be really careful when you're separating your variables. Your dy needs to be in the numerator and your dx needs to be in the numerator. So let's find the general solution of the differential equation for the next three examples. I have dy dx is equal to 2x plus 1. The first thing I notice is that on the right-hand side, I have just the variable x and some constants, so those can all stay together. But on the left-hand side, I have a y and I have an x, so I need to move the dx to the other side of the equal sign because I need to get it out of the denominator. So if I multiply both sides by dx, I end up with dy is equal to 2x plus 1 times dx. Now I have all of my x's on the right and all of my y's on the left. Since I've separated my variables, I get to integrate both sides. So I get to integrate dy and I get to integrate 2x plus 1 dx. Now the integral of dy is just going to be y plus some constant of integration. I'm going to call it constant sub 1. And that's going to equal, well, the integral of 2x is going to be 2x squared over 2 plus the integral of 1 is just going to be x plus some constant of integration. I'm going to call it c sub 2. Well, if I want to get y alone on one side of the equal sign, I'm going to need to move this constant of integration to the other side. Well, when I move c sub 1 to the other side, it just gets absorbed into a bigger constant of integration. So we can just rewrite this as y equals, these two cancel, x squared plus x plus c. Now typically what we're going to do in this class is go straight from this integration line to this line. What I tell students is you're only going to ever add one constant of integration, and typically most of the time you're going to want to solve these guys for y, so you'll only add the constant of integration to the side where your x's are. Let's do number 2. We have dy over dx is equal to 3y. So notice we have a y on the left and a y on the right and an x on the left. So I need to move that dx out of the denominator, so I have to multiply both sides by dx. So I end up with dy is equal to 3y dx. Now I have to get this y on the other side over here with dy. It's just being multiplied by 3, and since 3 is a constant multiplier, I can leave it on the right hand side. I don't have to bring it with me, so I'm going to leave it there on the right, and I'm just going to divide both sides by y to get all my y's on the same side. They'll cancel over here, and then we have dy over y is equal to 3 dx. Now that I have all my y's on the same side of the equal sign and all my x's on the same side of the equal sign, I get to integrate both sides. So I get to integrate the left and integrate the right. Well, what is the integral of dy over y? Well, that's just the natural log of the absolute value of y. Now remember, I'm only going to put the plus c on the right hand side with the x's, so I don't write it and I just write equals. Well, the integral of 3 dx is 3x and then plus c. Well, now if I want to solve this for y, I have to get y out of the natural log's argument. In order to do that, what I can do is I can make e the base, and I can raise e to this equation. So we can say e raised to the natural log of the absolute value of y is equal to e raised to the 3x plus c. Since e and natural log are opposite operations, here those two are going to cancel and you're just left with the absolute value of y, but since the exponential is never negative, there's nothing you can raise e to so it becomes negative, we can just write y here, don't need the absolute value bars anymore, and that's going to equal e to the 3x plus c. Well, e to the 3x plus c, remember, is equivalent to e to the 3x times e to the c, because we know if we have x squared times x cubed, that's just going to be x to the 2 plus 3, so all we're doing is moving from the part where they're added back to the multiplication side. Well, e to the c is just a constant. Since e to the c is just a constant, we rewrite that as the constant of integration. So y in the end is going to equal c times e to the 3x. Let's do number 3. Well, number 3 is xy plus y prime equals 100x. The first thing I need to do is get rid of y prime and rewrite it as dy dx. So we have xy plus dy dx equals 100x. Now I want to move this xy over to the other side because I'm going to need to get dx out of the denominator, and so I really want dy dx to be isolated on one side of the equal sign before I start doing anything else. So if I subtract both sides by xy, I get dy dx is equal to 100x minus xy. Now notice on the right hand side here that I have x in one term and x in another term, so I can factor that x out of those two terms. So I end up with dy dx is equal to x times 100 minus y. Now that's really helpful because again I need to separate variables. I have a y here in the numerator and then a 100 minus y on the right hand side, so I'm going to have to divide both sides by 100 minus y to get all my y's on the same side. And I have an x in the numerator over here on the right and that dx in the denominator, so I have to multiply both sides by dx to get that on the right hand side and separate my variables. I write dy over 100 minus y equals x times dx, because again I multiplied both sides by dx to get this guy out of the denominator, and I divided by that 100 minus y to get that over onto the left hand side. Now that I've separated my variables, I can integrate both sides. Well, the right hand side is pretty easy to integrate, x dx, we know what that is, but the left hand side is dy over 100 minus y. That's going to require a u sub. If u is equal to 100 minus y, the derivative du is going to equal negative dy. Well, I don't have a negative dy, I have a positive dy, so I can divide by negative 1 or multiply through by negative 1 and get negative du is equal to dy. Therefore, this guy over here becomes the indefinite integral of negative du over u. Well, I know how to integrate du over u, so that's ready to go, and I'm just going to copy this guy back down here so I integrate both sides at the same time. I'm going to move us to the right because we ran out of space. Integrating negative du over u, we'd end up with negative natural log of the absolute value of u, and that's going to equal, integrating x dx, we have x squared over 2 plus c. Remember, I typically only add the plus c to the side where I integrate the x's. Well, first I want to get out of u's and go back into y's, so this becomes negative natural log of the absolute value of 100 minus y equals x squared over 2 plus c. Now I want to solve for y. Well, there's that negative in front of the natural log, so the first thing we really want to do is multiply both sides by a negative to get rid of it. That leaves us with the natural log of the absolute value of 100 minus y over here on the left hand side, and then this becomes negative x squared over 2 still plus c, because when you multiply c by negative 1, it's still just a constant of integration. That negative 1 gets absorbed right into c, and we just still say plus c. Now make e the base. E raised to the natural log of the absolute value of 100 minus y is going to equal e raised to the negative x squared over 2 plus c. These cancel and we just have 100 minus y equals, and over here remember we write it as c e to the negative x squared over 2, just like we rewrote this guy over here. Again, I need to solve for y. So we're going to start by subtracting both sides by 100, and we get negative y is equal to c e to the negative x squared over 2 minus 100. Last and final step is going to be to divide by a negative. Now, because c is now multiplied by something with x's, it will no longer absorb any number that we add to it or any number that we multiply it by. So when we divide by a negative now to get rid of this negative here, we're going to need to make this a negative c e to the negative x squared over 2. And then this 100 becomes plus 100. Again, it changed this sign here to a negative because it can no longer absorb it like it did up here, because it's not just a constant integration all by itself. Now it's being multiplied by something that has an x in it. So we end up here with y is equal to negative c e to the negative x squared over 2 plus 100. Let's look at number 4. Number 4 is asking us to find the function y equals f of t passing through the point 0, negative 5 with a given differential equation dy dt is equal to negative 3t. Now the difference between number 4 and numbers 1, 2, and 3 is that this time we're given a point on the original function. Since we're given a point on the original function, and this point is t equals 0, y equals negative 5 over 2, we have enough information to solve for c once we solve our differential equation. So we're going to still solve the differential equation like we did before using separation of variables. We have dy over dt is equal to negative 3t. So just like last time, we're going to take this guy over here and push it over to the t's. This becomes dy is equal to negative 3t dt. Now that we've separated, we integrate both sides. We integrate the left and we integrate the right. The integral of the left, the integral of dy is just y, and that's going to equal the integral of negative 3t dt is negative 3t squared over 2 plus that constant of integration. Now what we want to do is use the given information to solve for c. Well, again, we know that when t is equal to 0, y is equal to negative 5 halves. That means that negative 5 halves has to equal negative 3 times 0 squared over 2 plus c. Solving for c, well, that's just 0. c is going to equal negative 5 halves. Therefore, the function that passes through that point with the given differential equation is going to equal y equals negative 3t squared over 2 minus 5 halves.